sustainability and environmental traits of different energy systems. Okay, this third unit we have to discuss what about that is called sustainability and environmental traits of different types of energy systems. Okay, so these are the different types of energy systems. Classification of different types of electrical storage technologies, like energy systems. Okay, different types of energy storage technologies. So there are four types of energy storage technologies. So under this, according to our syllabus, so we have to concentrating on mainly on pumped hydro storage systems, and next one high efficiency batteries like lead acid batteries, lithium ion batteries, and double layer capacitors like okay high efficiency batteries. Next, main important concept is called superconducting magnetic energy storage system (SMES). Okay, so like this, these are the different types of energy storage technologies. Okay, so mechanical storage systems is classified into three types. First one is called pumped hydro storage systems. Generally, is called PHS. Pumped hydro storage systems. PHS. Mechanical. It comes under mechanical storage systems. Okay. The next one is called compressed air energy storage systems. CAS. Compressed air energy storage system. And then next flywheel energy storage system. So here pumped energy hydro storage systems store the energy in the form of potential energy. So that is called water. In upper reservoir, we have to store the water in terms of potential energy. Okay. And the next compressed air energy storage system. So by compressing the air, we can store the energy. That is comes under compressed air energy storage, CAS. Then flywheel energy storage system in terms of mechanical, that is called kinetic energy, in terms of kinetic energy. Okay, moment of inertia, based on moment of inertia, kinetic energy. We have to store the energy in the form of kinetic energy. So that is called flywheel energy storage system. So these three comes under mechanical energy storage systems. Okay. The next electrochemical storage systems. Electrochemical reactions takes place inside of these storage systems. Electrochemical, electrical and chemical reactions takes place. That is called lead acid batteries, lithium ion batteries, flow batteries. Okay. And the next chemical energy storage systems generally is called as hydrogen, H2, and synthetic natural gas, essence. These two comes under chemical energy storage system. Then last one, electrical energy storage system. So in this, one of the high efficiency batteries like double layer capacitors, double layer capacitor, and next superconducting magnetic energy storage system, SMES. And next final last one is called thermal storage systems. So these are the different types of energy storage technologies, classification of energy storage technologies. Then coming to the one by one, so according to our syllabus, JNUH syllabus, main important concept is called pumped hydro storage systems, and the next one, high efficiency batteries like lead acid batteries, lithium ion batteries, and next double layer capacitors like this. And the next is important concept is called superconducting magnetic energy storage systems. So these are the important concepts under Unit 3. So first, pumped hydro storage systems, PHS, pumped hydro storage system. So this is the diagram, schematic diagram of pumped hydro storage systems, PHS. It is having main two components, so upper reservoir and lower reservoir. There are two main important reservoirs called upper reservoir and lower reservoir, pumped hydro storage systems, PHS. Okay. So here store energy in the form of kinetic energy, potential energy, upper reservoir. We have to store the energy and in the form of potential energy in the upper reservoir. Okay. This is called upper reservoir and the lower reservoir. So in between there is a penstock. Okay. This penstock is used to recover the water, whatever the water in the upper reservoir is collected and passing to the turbine. The turbine is rotating. Okay, that is called penstock. Penstock is like a pipe. It's nothing but like a pipe to carry the water from upper reservoir to lower reservoir to the turbines. Okay, so this is called diagram of pumped hydro storage systems, and the main important concept is called lower reservoir and the rest upper reservoir. So in this, one of the main important concept is called powerhouse, that is called turbine. This is called pump or turbine. This is also one of the main important component and pumped hydro storage system. This is called turbine, and this is called low reservoir, upper reservoir. And this is called as a penstock. Penstock is like a pipe to carry the water from high upper reservoir to lower reservoir and passing through turbines. And turbine is rotating. Okay. See here, the energy stored in the upper reservoir is called potential energy, MGH. Potential energy. So when the control valve is open, that potential energy is converted into kinetic energy. Okay. That kinetic energy is again converted into mechanical energy by using turbine. The turbine is rotating because of this kinetic energy. Okay, turbine is rotating. That is called mechanical energy. So from mechanical energy is connected, mechanical energy is nothing but mechanical output. This mechanical output is connected to the generator, and generator is rotating, and then we can get the electrical output, electricity. So that can be collected by powerhouse and transmitted to the by using transformer, increase the voltage and connected to the grid. This is called transformer. Okay. Like this, pumped hydro storage system is work. Okay. Pumped hydro storage. So this is called to generate the electricity. Two directions, the power flow takes place. Two directions. Under light load condition, under heavy load condition. This can be used as a source. Under heavy load condition on the grid, pumped hydro storage systems can be used as a grid. Okay. Under heavy load conditions. It is as act as a source. It generates the electricity under heavy load condition on the grid to supply the electricity to the grid to the transmission lines. That is called pumped hydro storage. It acts as a when the water is passing from upper reservoir to lower reservoir, turbine is rotating, you can get the electricity and that fed to the grid. Okay, that is called generation of electricity. So under light load condition, so what happened means whatever the water stored in the lower reservoir, that can be pumped back to upper reservoir. Okay, that is called under this act as a load. Okay, and this whatever the motor used here, that machine used here, that machine acts as a motor. Okay, under generation condition, this motor acts as a this machine acts as a generator. Under pumped storage condition, to pump the water from lower reservoir to upper reservoir, it acts as a motor, like pump. Pump the water from lower reservoir to upper reservoir by taking the power from the grid. Reverse process. Under light load condition, during nighttime conditions, the load on the system is very less. The load on the grid is very less. That's why it take the power from the grid and transfer the water from lower reservoir to upper reservoirs. So under this condition, the machine acts as a motor and pump the water from lower reservoir to upper reservoir. Okay. So this is the water flow when pumping. Water flow when pumping, like a charging. Okay, water is increases. When pumping the water from lower reservoir to upper reservoir, your water increases. Nothing but potential energy increases. Water flow when pumping, that is nothing but charging. And water flow when generating, it means discharging. It generates the electricity and pump to the transmission and generate the electricity and fed it to the grid. Okay, that is called discharging. Charging and discharging process. This is called pumped hydro storage system. Okay, so you can understand from this diagram also easily. So this is called higher level reservoir, lower level reservoir, and the flow of water to generate the electricity. Okay, potential energy is converted into kinetic energy to mechanical energy to electrical energy. Like this, energy's conversion takes place. Okay, flow of water to generate electricity in this direction. Okay, that is called discharging. generation of electricity and discharging of water from higher level reservoir to low level reservoirs. Okay, that is for generation of electricity. And to use the electricity under light load condition, low electricity demand. Under this condition, it can be used as a that electricity and the motor, whatever the machine you are using, that can be act as a motor and to pump the water from lower reservoir to upper reservoir. Like this. These are the two operations, charging and discharging. Okay, flow water during the pumping. Like this. This is the two way of direction of water. So under heavy load condition, it can act as a generator. It can act as a source. PHS, pumped hydro storage system, acts as a source. When the load on the grid is high. When the load on the grid is less during nighttime condition, nighttime or also winter season, the load on the system is very less. So at that condition, so we have to take the power. PHS, pumped hydro storage systems, take the power from the grid and whatever the water is available on the lower level reservoir and it's pumped back to high level reservoir. So like this is the operating principle of pumped hydro storage systems. Very simple. Under high load, very under high load conditions, heavy load conditions, it can supply the power to the grid. Okay, by generating the electricity, by using the water from high level reservoir to transferring the water from high level reservoir to low level reservoir. So generate the electricity and feed it to the grid and maintain the stability of the system. Oh, okay. During nighttime conditions, winter seasons, some seasons, the load is very less. At that condition, it take the power from the grid and low level water is pumped back to high level water. That is called charging, discharging, like this process. Okay, this is about circuit diagrams of schematic diagrams of pumped hydro storage system. So, coming to the concept, so yeah. So, what is the energy stored in this reservoir is called potential energy. Potential energy storage in elevated mass is the basis for pumped hydro storage system. So, here upper reservoir. Here, potential energy storage in elevated mass is the basis for pumped hydro storage systems. So, like this. Okay. And energy used to pump the water from lower reservoir to upper reservoir. Here, energy used to pump the water from lower reservoir to upper reservoir under light load condition. When the load on the grid is less, at that condition, whatever the energy is available, that can be used and pump the water from low level reservoir to upper reservoir. That is called as a like charging of this pump PHS, pumped hydro storage system. Okay. So discharging means it generates the electricity. So that is concept. Electrical energy is input to the motors. Electrical energy input to the motor and is converted into rotational mechanical energy and pumps the transfer energy to the water and kinetic energy, then potential energy. Okay, like this pumped hydro storage systems work. Okay, energy stored in water of the upper reservoir, energy stored in the water of the upper reservoir, released as a water flow, like this. Water flows to the lower reservoir. So that means potential energy is converted into kinetic energy, and this kinetic energy is converted into mechanical energy. Okay. So falling water comes to a turbine, and then turbine is rotating, then we can generate the electricity. There is a mechanical coupling between turbine and generator. The turbine is rotating, this generator shaft is rotating, we can get electricity. Turbine turns the generator, and then we can generate electricity. That is called converts mechanical energy to electrical energy. Okay, this is the operating principle of pumped hydro storage systems. Okay, so next main important concept. Typically, pumping would take place by buying electricity during times when prices are low. So when the price on the grid, when the price on the is are low, so at that conditions take the electricity from the grid and it can utilize it to pump the water from low level reservoir to upper level reservoir. So pumping would take place by buying electricity during times when the prices are low. When the price of the electricity is very less at that condition, it take the electricity and which is when demand is low or availability of electricity from the sources I. Okay, that is called under light load condition. It take the electricity and pump the water from lower reservoir to upper reservoir. Generation would takes place when generation takes place. So during times of high demand, when the grid, when the demand on the electricity, when during summer season, the electricity demand is high. More amount of electricity demand during summer season. Okay, generation would take place during times of high demand, such as during evenings or summer seasons. Based on the seasons, the load on the system is changes. During summer season, load on the grid is very high. At that condition, it can act as a source. Okay, when prices are high. So this pattern of buy low and sell high is called arbitrage. Okay, so like this is the operating principle. It is working in this way. Okay, the power companies make a lot of money by selling the generated power during peak hours at higher rates. Okay, this is the advantages. Under heavy load condition, heavy demand condition, it can act as a source. Under light load condition, it can act as a load. Okay, this is the operating principle of pumped hydro storage system. So pumped hydro storage system. So uh, this is some introduction that is called historical development of the PHS. The history of pumped storage plant can be traced for back as 1882. Okay, the first hydroelectric plant is making of use of pumped hydro storage function in Switzerland. So first pumped hydroelectricity, hydroelectric plant is making in 1882 for the, in Switzerland. Okay, so 1931 is the first reversible pump. Reversible pump turbine was installed in Germany. In 1931 is the first reversible pump. Okay, reversible pump. Whatever the motor you are, whatever the machine you are using, same machine can act as a motor and generator. During generating condition, it acts as a generator. Turbine is rotating, we can pump the water. We can generate the electricity. That is called for generation condition. When the load on the system is less, take the power from the grid, it can act as a motor. Same machine acts as a motor and generator, and this pen stack it acts as a pump. Okay, pump the water. So first reversible turbine was installed in 1931 in Germany. Then the major reversible diagonal turbine, this is called one of the turbine. The name of the turbine is called Derich turbine, was installed in Niagara in 1955. Okay. So in Europe in 1962, so the total capacity of 360 megawatts with the head of 284 meters. Okay. So one of the turbine is installed like this, the rating of the turbine. Okay. So this was historical development, and the pumped hydro storage systems, so PHES, can be classified into two types. So one is open loop and the second one is called closed loop. Open loop or closed loop. Two types of hydropower plants, pumped hydro storage systems are classified. Okay, this is called as a open loop, conventional river based pumped hydro storage system. Open loop or conventional river based pumped hydro storage system. So concentrating on here 1, 2, 3, 4, four important main points regarding to the pumped hydro storage system. First one, mainly existing in PHA systems have been developed in conjunction with a conventional river-based hydroelectric system. Conventional river-based hydroelectric system. Okay. Conjunction with a conventional river-based hydroelectric system, generally. Okay. So two reservoirs are located, are created at different altitudes. So this is one altitude and this is called lower reservoir and this is called upper reservoir. Two reservoirs are created at different altitudes, but close to each other. The distance between these two reservoirs are less. Okay, approximately 1 kilometers or 500 meters maximum. Okay, the distance between these two reservoirs are very less at two different altitudes. So upper reservoir and lower reservoirs. The two reservoirs are created at different altitudes, but close to each other. It's all connected through a pipes, penstacks. These two reservoirs are connected to the penstacks, and this water is collected from the upper reservoir to lower reservoir, and turns the turbine, and turbine is rotating. You can generate the electricity. Okay. So often the lower reservoir is large and located on the substantial river. So it is called substantial river, while the upper reservoir is a smaller. Upper reservoir is a smaller and located higher upon the same river or in a high tributary or parallel valley. So this is some related information. So regarding this about open loop hydropower plants, most river water passes through the system, generate electricity. So most amount of water here to generate the electricity, passing water from upper reservoir to lower reservoir. Most river water passes through the system, generate the electricity, then flows on down the river. Okay, some water is cycled between two reservoirs to create energy storage. So during summer season, the water availability on the upper reservoir is less at that condition. Whatever the energy, whatever the water available in the lower reservoir can be utilized to pump the back and under light load condition during nighttime condition. And at daytime condition, the energy requirement is more at that condition. It can be act as a source, okay, and we can generate the electricity and fed to the grid. Okay, this is called open loop or conventional river based pumped hydro storage systems. And then off river, that is called as a closed loop pumped hydro storage system. Okay, pumped PHESS can be classified into two types: open loop and closed loop. Open loop is nothing but based, conventional river based PHES, and closed loop is called off river or pumped hydro storage systems. Okay, so this is the some important informations regarding this pumped hydro storage systems. So first one, there are alternative methods of constructing BHES do not require significant modifications to the river systems. So here there is no modifications to the river systems. This is act as a upper reservoirs and this is called as a lower reservoirs. There is no modifications, not require significant modification in between two reservoirs. Okay. One method is to connect closely spaced existing reservoirs using underground tunnels. So underground tunnels, by using underground tunnels, we can, and underground powerhouses, you can generate the electricity. Okay. So this is called as a closed loop system, but in it's look like visible. The turbine and powerhouse and penstacks are visible, and lower reservoir, upper reservoirs are all are visible. But in closed loop system, there is no visible of this lower turbines and also powerhouse. This is existing on the underground. Okay, closely spaced existing reservoirs using underground tunnels and powerhouses with care, and there is a low disturbance at the surface. Okay, low disturbance at the surface. It's called as a closed loop off river hydro systems. Okay, and off river PHES systems comprises a pair of artificial reservoirs. Pair of artificial reservoirs. These are the three. Okay, here. There is a pair of artificial reservoirs. Okay, spaced several kilometers apart, located at different altitudes. This is on ground level. This is called top level, upper level. Okay, so at located at different altitudes and connected with a combination of aqueducts, pipes, and tunnels. Okay, by using like this pipes and tunnels, we can connect these two in the underground of this half river based pumped hydro storage systems. The reservoirs can be especially constructed. It's called as a green field, okay, and or can be utilized old mining sites or existing reservoirs is called as a brown field. Okay, this called two fields are there. There are two fields. First one is called green field and the second brown field. So the reservoirs can be specially constructed is called as a greenfield reservoirs, or can be utilized old mining sites. Old mining sites are existing reservoirs is nothing but a brownfield reservoir. Okay, this is and next off river PHs utilize conventional hydroelectric technology for construction of reservoirs, tunnels, pipes, powerhouse, electrochemical equipment, control systems, shared and transmission. So this is the information regarding off river pumped hydro storage. Like this is the concept regarding pumped hydro storage systems for off river and for open loop, that is PHS, conventional river based PHS, and off river closed loop pumped hydro storage system. Okay. Next, comparison between these two. So this is called open loop and this is called closed loop. So these are the different comparisons are there here. So an off river PHS system has advantages that flood mitigation costs are minimal compared to with the river-based PHS. So because of these are constructed in the underground tunnel, that's why there is no effect of flood mitigation problems and costs in off river base. But here there is a flood mitigation problems that takes place in open loop system, conventional based PHS. Okay. And next, heads are generally better than river based systems. Heads are generally better than river based systems because of upper reservoir can be on a higher hill rather than higher the same valley at this lower reservoir. So, okay. So this is the comparisons of different of these two. Okay. Lower loop reservoir and upper and closed loop, open loop system and closed loop system. Okay. So this is about pumped hydro storage systems and is having different types of components of pumped hydro storage systems. So components of hydro system BHS is nothing but so major components are nothing but lower reservoir, upper reservoir, penstock, surge tank, powerhouse, ALS, turbines, or like this. So these are the main important components of pumped hydro storage system. Okay, so pumped hydro storage upper and lower reservoirs are separated by elevation difference. That is called upper and lower reservoirs and open loop and two configurations, open loop and closed loops. Okay, one of the next important component is nothing but penstock. Penstock is a conduit of water flowing between the reservoir and the pump or the generator. So penstock is like a pipe to collect the water from upper reservoir to lower reservoir, and when the water is falling on the turbine is rotating. Okay, so there are this is called PHS and TLS terminal such tanks. So this is about pumped hydro storage system. Okay. So these are the different types of turbines. So power generation take like this. So here two ways: generator, turbine. Turbine is rotate the generator and generate the electricity. Motor pump the water using the pump like this. Act as a pump to pumping the water from lower reservoir to upper reservoir. Motor is required, and to generate the electricity when the water is flowing from high reservoir to low reservoir, so generator is required. The turbine is rotating and generator. This is called quaternary set. And just ternary set is nothing but same machine act as a motor and generator and turbine and pump. So this clutch is used to control this water. To operate the turbine mode or to operate pump mode, the clutch can be used. Okay. To generate the electricity, the turbine is operated. To pump the water, motor can be operated. It acts as a motor. Okay. So these are about pumped hydro storage systems. These are the different types of turbines. Francis turbine, it looks like a Francis turbine. And next, this is another way of Francis turbines looking like this. And turbine, okay. And next is another turbine, Pelton turbines. So Pelton turbine is like this. So these are the turbines are used in pumped hydro storage systems. Okay. Next, coming to the so what are the losses in pumped hydro storage systems? While pumping the water from higher reservoir to lower reservoir, okay. So like this takes place energy conversion. Pumping means it acts as a motor. Machine acts as a motor and pump the water from low reservoir to upper reservoir. That is called charging. So, okay, charging. So here 100% input to the motor is called 100%. There is a waste which takes place in the transformer 0.5%, motor 2%, pump 10%, penstock 1%. Like this, there is some small amount of considerable small amount of losses takes place. That remaining energy is called 86.8%. Yeah, store the energy. So losses in BHS, so losses. So 100% to 86.8% is reduces losses when pumping the water from lower reservoir to upper reservoir. The small amount of power is waste. Energy waste takes place across the transformer 0.5%, motor 2%, pump 10%, and penstock 1% takes place like this classes. And then under heavy load condition, we have to generate the electricity by using PHS. So whatever the energy here that can be utilized and water that is upper reservoir to lower reservoir. When water is pumping upper reservoir to lower reservoir, generate the electricity. Okay, like this. So output is called 77.6%. Here 86.8% to 77.6% changes like this. 100 to 77. Approximately 23% of energy is wasted while pumping. Okay. This is the because of losses, because of and stuck 1% turbine, 7.5% generator, 2% transformer, 0. So these are the some losses takes place in pumped hydro storage system. Then next coming to the what are the advantages of pumped hydro storage system? Relatively low capital cost, the economic source of peaking capacity, very less low capital cost, and also running cost is also very less in pumped hydro storage system. Rugged and dependable, can pick up load rapidly in a matter of few minutes. In pumped hydro storage systems, to generate the electricity, it is very less time to meet power demand in pumped hydro storage systems. Okay, to get the rated speed of turbine is very easy by opening the valves, and then kinetic energy is converted into mechanical energy, and we can get the required electricity, rated electricity. Okay, in pumped hydro storage systems, very less can pick up load rapidly in a matter of few minutes in pumped hydro storage system, but not in other sources like, for example, thermal. In thermal energies, thermal system, thermal power plants, to get rated speed, approximately 1 day is required. Okay, to get rated speed of the turbine, approximately 1 day, 24 hours is required to get synchronous speed of the motors, turbines. Okay, that is the difference. But in pumped hydro storage systems, only few minutes we can reach the demand. Okay, that is the one of the advantages of this pumped hydro storage system. Readily adaptable to automation as well as remote control. This is one of this next advantages of this pumped hydro storage system. Hydropower is free from effects of environmental pollutions. So free of energy, we can generate electricity with free of energy without maintenance. There is no environmental pollutions. Okay, that contributing part in curbing air or water pollutions. Okay, so this is the advantages, some advantages of this. Okay, readily adaptable to automation as well as remote control, and pick up load rapidly a matter of few minutes. These are the main advantages of this PHS. Next, allow great deal of flexibility in operational schedules of systems. There is a flexibility in increase the demand or decreasing the demand. Okay, is possible in pumped hydro storage systems. To increase the generation capacity is few minutes only, and also to decrease is also very easy in a pumped hydro storage system. Okay, power is required for pumping is available at a cheaper rate. Okay, slack hours rate. So, for example, during night-time conditions and also during winter conditions, the power cost is very less at that condition. At pumping the water is at a cheaper rate, and power is produced, it can be sold at a prime rate. Peak hours. Okay, peak hours we can we can generate the electricity and we can sold at a higher rate. So this is the advantage of this for PHS. Okay, this compensates the low hydraulic efficiency. Okay, these are the advantages. Next, they allow enter thermal or nuclear power generation to take up as base load. Okay, By interconnecting of this hydro power plant and thermal power plants, we can maintain the load on the system like a base load system. They allow entire thermal or nuclear power generation to take up base load. Okay, very easy. Thus, the load factor increases and giving overall greater system efficiency. So, by integrating these two hydropower plants and the thermal power plants or nuclear power plants, we can increase the efficiency of the system. Little effect on the system. Okay, so this is about comparative system and is having also some disadvantages. Okay, disadvantage is called first one, environmental issues like water uses, river, habitat disruption. So this is one of the disadvantages of PHS. Head variations. Pressure drops are as upper reservoirs and drains. Okay. Head variations is called as one of the disadvantages. Environmental issues also one of the problems. Sitting options are limited. Availability of water, favorable topography, large land area. Some drawbacks, disadvantages of this PHS, pumped hydro storage systems. Okay. Problems of operation of pumped hydro storage systems. So what are the problems? Once it is used, it cannot be used again until the water is pumped back. When the upper reservoir is water is over, it is very difficult to generate the electricity. So until pumped back into the upper reservoir. Okay. So this is the problem. Once it is used, it cannot be used again until the water is pumped back up. Okay. That is one of the problem in pumped hydro storage. Cavitation problems. This is also one of the problems. Powerhouse locations has to be fixed. So fixed that pump operates under submerged conditions. That is called cavitation problems are also takes place. And the reversing of direction of flow gives rise to a runner cracking due to fatigue. Fatigue. So this is because of this, there is a runner cracking takes place due to fatigue. Trash racks vibrate violently during pumping operation. So these are the different types of problems facing on pumped hydro storage. So this is about complete information reading regarding pumped hydro storage systems. Okay. So first pumped hydro storage systems. First one, classification of pumped hydro energy storage technologies. Next, diagram, schematic diagram of pumped hydro storage systems. Upper reservoir, lower reservoir, and generate the electricity when water is flowing from upper reservoir to lower reservoir, and turbine rotates and generate the electricity. This is called discharging. And charging is nothing but whatever the water in the lower reservoir that is fed back to upper reservoir. Okay, that is called charging. This is another way of diagram representation. And what are the main components of this pumped hydro storage systems? Upper reservoir, lower reservoir. What is the use of these two? And penstock and powerhouse. Okay, and the classification of pumped hydro storage systems. That is called open loop and closed loop, open loop. Conventional river-based PHS and off-river based, that is called closed loop pumped hydro storage systems. This classification of two pumped hydro storage systems, PHS. Okay, and next comparison and components and turbines. What are the different types of turbines are using, and what is the working? And next, these are the different types of turbines, and what are the losses takes place in PHS, and next, what are the advantages, disadvantages, and next problems. This is about complete information regarding pumped hydro storage systems towards the sustainable energy. Okay, in future. Next, coming to the another energy storage technology that is called compressed energy storage systems, CIS, compressed energy storage systems. We have to take the energy, we have to store the energy. Yeah, when under light load condition, we are taking the power from the grid and take and by using motor and you can compress the air in cavern. Okay, so this is called compressed air. Under light load condition, under heavy load condition, whatever the compressed air is can be used as to generate the electricity. That is called discharging, charging and discharging. This is called compressed air energy storage systems. Okay, this is called motor and compressor and use when light load condition take the electricity from the grid and store the energy here. And under light load condition, under heavy load condition, it can act as a source. And so by using high pressure turbines and lower pressure turbines, And we can generate the electricity and fed to the grid again. So charging and discharging. This is called compressed energy storage system. Okay, there are different types of processes of compressed energy storage systems. Okay. This is about compressed energy storage systems. And next, coming to the next concept, flywheel energy storage system. This is also flywheel energy storage system. Flywheel store the energy in the form of kinetic energy. Is rotating. Heavy weight body is rotating like this. I take the energy from the grid and I can. This is called motor. I rotate this body. So heavy body is rotating, the heavy mass body. So it stores the energy in the form of kinetic energy. Okay. So like this, it's charging. Take the energy from the grid like charging. Under light load condition, this motor acts as a generator and pump it back to the reverse to the grid. This is called flywheel energy storage system. Okay. So these are the different types of components of flywheel energy storage system. And the next advantages and disadvantages applications of flywheel energy system. Next, lead acid batteries. High efficiency batteries is called lead acid battery. What is lead acid battery? So chemical reactions takes place inside of the battery. The battery which uses spotulate and lead peroxide, two electrodes. Okay, for the conversion of chemical energy to electrical. Such type of battery is called lead acid battery. So one electrode is called spotulate and one electrode is called lead peroxide. Okay, that is nothing but lead acid battery. Commonly used in power stations and substations. Power stations and substations. This type of batteries are generally used. Okay, lead acid battery contains like this 6 cells, 2 volts each. This is called lead acid battery. Construction is look like. One is cathode, one is anode. Cathode is called linked plates with grids filled with lead oxide, PbO2, lead oxide. And another anode is called linked plates with a grid filled with sponge lead. Okay, and plate separator is called separator. Okay, what is lead acid battery? So, what is this is called some introduction regarding this. Battery is a storage device which store the power, you know, and is having 6 cells which having each cell has at 2 volts. So materials lead peroxide, PbO2, sponge lead Pb, and electrolyte, dilute sulfuric acid is called electrolyte, H2SO4. Okay, it is the ratio of H2SO4 and water is the ratio of 3:1. Okay, positive plate is called lead peroxide and negative plate is called lead acid, sponge lead. Okay, so this is called construction of lead acid battery. So anode lead peroxide, cathode lead, pure lead, and this is called electrolyte and sulfuric acid and distilled water. This is called one of the high efficiency battery. Okay, lead peroxide and pure lead. This is called reactions during discharging of lead acid battery. Whatever the reactions that takes place. So at the anode side, these are the reactions. At cathode side, these are the reactions. Okay, during discharging condition, lead peroxide PbSO4, lead sulfate PbSO4 concentration increases PbSO4. During charging condition, H2SO4 concentration increases when it is connected to the source. When it is connected to the source, it acts as a charging. When connected to the load, it acts as a source discharge. Okay, these are the reactions at anode and cathode. Okay, so what are the benefits and are advantages of lead acid battery? It is available in all space and sizes. So one of the advantages. It does not require any maintenance. Best in terms of reliability and working capabilities. Okay, with chance slow or fast overcharging. Capable to withstand long-term inactivity with or without solvent. Offers best value of power and energy per kilowatt hour. Offers longest life cycle. About 97% of lead can be recycled. So these are the some benefits or advantages of lead acid battery. It is also having some disadvantages, drawbacks, and okay. So drawbacks of lead acid battery is called lead is heavier compared to alternative elements. One of the disadvantages. specific energy, low specific energy, poor weight to energy ratio. So it can be charged slowly and fully saturated. Charge takes place 14 to 16 hours. To take fully charge, minimum 14 to 16 hours are required. Okay? Lead acid batteries and must be stored in charged condition in order to prevent sulfation. Always connected to the source only. So must be stored in charged conditions only. 24 hours is connected to the source. Okay. Otherwise, there is a sulfation problems that takes place inside of the battery. Lead battery. Okay. It is not environmental friendly. So these are the drawbacks of lead acid batteries. Next batteries have efficiency batteries called lithium ion batteries. So lithium ion batteries. So this is called lithium ion batteries. So there are different types of batteries, primary batteries and secondary batteries. Lithium ion battery is a rechargeable battery. In this, reactions are reversible. Okay, primary batteries are only one time. Secondary batteries are can be recharged. Okay, rechargeable batteries. Reactions are reversible and secondary batteries. Okay, lithium ion batteries. In this, lithium is the lightest of material, and it can be float on water. So lithium is the lightest of metals. That's why nowadays we are using mobiles lightweight. Lithium is the lightest weight metal. That's why. So in mobiles, the lithium and batteries are generally used. Electronic applications generally. So electrochemical properties of lithium are excellent, and it is also highly reactive material. So that's why electrochemical properties of lithium are excellent. That's why lithium can be used in mobile batteries. Okay. These properties gives the lithium potential to achieve very high energy. Energy density of this lithium ion batteries are very high compared to other batteries. Okay. So that's why the efficiency of the battery is very high. Okay. Lithium ion batteries are primary batteries in which the lithium metal compounds. So this is some information is about this lithium ion batteries. And here lithium materials working principle. So here lithium cobalt oxide is called anode and cathode is called graphite and electrolyte is called potassium hydroxide. Can be used in lithium batteries. Okay, this is the working construction and working principle of okay lithium ion batteries. So work construction and this is construction. So lithium cobalt oxide is called anode and graphite is called cathode and these two are separated by one separated. Okay, and by using some insulations we can separate these two lithium anode and cathode. Okay, so these are the cell reactions during anode at cathode. The reactions are reversible, two-way reactions. Lithium cobalt oxide is completely converted into lithium ion, okay, lithium ions like this. And these lithium ions are using and graphite plates and it acts as a lithium graphite. So like this. So these are the reactions regarding the lithium ion batteries. So working principle and construction lithium battery. Okay, it's having some advantages and disadvantages. Advantage of lithium batteries called they have high energy density. They are very less weight. They produce high voltage about 4 volts as compared to other batteries. Okay, fast charging and discharging rate also. So it's having some disadvantages also. They are expensive. Cost of these lithium ion batteries are very high. Okay, cost of the lithium is very high. They are not available in standard cell types. Okay, this is about the advantage of lithium ion batteries. Okay, applications of lithium ion batteries. Next, lithium ion batteries are used in cameras, calculators, smartphones, and most of the consumer electronic devices. Lithium ion batteries generally used in electronic devices because the power density of these lithium ion batteries are very high. Okay, they are used in cardiac pacemakers and there another implantable devices also can be used. In electric vehicles also, lithium ion batteries are used. Okay, power tools to operate in the power tools, lithium ion batteries also can be used. These are the some applications of lithium ion batteries. Okay, so this is about lithium ion batteries. Okay, so this is enough today. So only one energy storage is enough. That is called uh, SMES, superconducting magnetic energy storage. That is only one concept is left over from the third unit.